Okay, morning. Uh, by the way, this model is last semester paper. This model. Okay. Uh, if I remove it, it's something like that. Okay. And then this is the other piece, which is attached over here. Okay. So let me place it back. If those who wants to take. Oops. You see, if I start now, a lot of you are still streaming in. So let me show you this model first. Yeah, something like that. Okay, something like that. If you want a plan, no problem. Okay, this is the plan. You want a close up? I can give you a close up. Okay, all right. Okay, let us continue with 20181972. Okay, all right. Instruction is still the same. So for this semester, the instruction is the same as the previous semester, not the lockdown semester. So four question, 1A, 1B, 2A, 2B, and then 3A. They are engineering graphics. 3B and question 4 is GD&T. All right. Okay, let us start. This question, 1A. Figure 1A. Let me read the question first, and then I will show you the solution. Figure 1A shows a solid prism and a rectangle uh, prism. Okay, presented in third angle. So this is plan. This is your front. Draw the incomplete front and yeah, just draw the incomplete front. Okay. Now, if you are going to visualize, it will be difficult. The best option or the best way, as I say, is for you to trace. How we do that? Very simple. You label your parts. If you don't label your parts, how are you going to trace? So please, number one, label your parts. That means these numbers 1, 2, 3, 4, 5, 6. Once you label it, you should be able to trace. Okay, let's do it. Okay, let me place the first slide. One, two, three, four, five, six. Yeah. Since this is third angle, you are doing in this manner. So your point one, or rather you will see point 4 first and then point 1. So 4, comma 1. Over here, you will see point 2, bring it across, bring it up, bring it across. You know that the whole line here is point 2. View here, point 3. When you view here, you bring it up, bring it across. This whole line here is point 3. Here. And then point 5, do likewise the same, point 6. So you know this will be 4, comma 1, 2, 3, 5, and 6. Simple as that. Okay, next slide. You see, I never ask you to visualize. I just ask you to trace. Okay. You know that point 4, comma 1 is this point. Okay. Okay. So you bring it down. Yes, bring it down. Okay, where is point 4 and point 5? Point 4 and point 1. If you are viewing from this direction, that is third angle, you view and you throw backwards, you would see your point 4 is here, so project backwards. So you get this point. Quickly label the part 4. Then point 1, okay, point 1, you bring it across where this line meets, that's point 1. So label this one as 1. Okay. So far so good, right? Okay. Next slide. Okay, let me remove slide 1. Then for slide 2, you do likewise the same. For point 2, where is point 2? It's over here and over here. Okay, you have one point of intersection here and here. You project down where it meets point 2, you have point 2 here. So you label the parts 2. And then don't forget that you have another point 2 here. Bring it down where it meets this 2, that is point 2. Okay, so you have already point 1 and point 2. So you already can join 1 to 2. Okay, we let me show you all the slides, and then we can talk about hidden details and outline. Okay, so for the time being, you have point 1, point 2, point 2, and point 4. Yeah. Okay. Let us do point 2. Sorry, point 3. Let me remove the slide 2, and then we have slide 3. Okay. Notice for your slide 3, point 3, your point 3 is here and here. So first point, project downwards where it meets point 3, because this is third angle. So you view from here and then you bring your view backwards. So that is 3. So quickly put a note there, 3. And then you have another point 3, which is here. If you know how to do this line, you obviously would be able to do this line. So project downwards, you get another 3. Yeah? Okay. So let me remove point 3 and then do a slide 4. See? So 0.4, if you know, you can do 1 and 4 together because roughly it is the same line. It is the same line. Okay? So that is 4. And then finally, you have 5. Okay? So you have 5. Where is 5? Your 5 is this line. So it's outside. So you have one complete line. Okay. Let me remove all of this and then let's us talk about hidden and visible lines. This is third angle. Third angle means your eyes is here. Okay, you are viewing in this manner. Should you be able to, let me take another pen. Okay, if your eyes is here, uh, 1 to 2, sorry, 3 to 4, if you view from here, you should be able to see this line. Okay, it's not blocked. So this line is darkened. 3 to 4, 3 to 4. This from here to here, from here to here. Because your eyes is here, you should be able to see this. This is a plane. So obviously 2 to 3 is behind this plane. So therefore, this is dotted line, hidden. So therefore, the other side is also hidden with 2 to 1 to 2 or 2 to 1. Hidden. Now, this portion from here to here, which is from here to here, yeah, is hidden definitely because it's blocked by this plane. Blocked by this plane from here to here. So roughly about here, which is this line. So this is hidden. All right, yeah. Now, so obviously 0.5. 0.5, when you view from here, definitely you can see this point. There's no blockage whatsoever. So one long line. All right. Okay. Any question before I proceed to the next one, 1A, A1B? Any question? No question. Okay. So some of you have asked me about this, and I told you all that I will do it today. So this is the solution. Okay. So this is the complete solution. All right. Yeah. Okay. Next question. This is a gift. The next question is actually a gift because it is part of your lecture notes. Okay. Now, if you give me obtuse angle, this is the obtuse angle, I will accept it. But if you give me acute angle, which is much better, that's a norm, would be preferred. Okay, now how do we do it? Slide 1. Oh, I have a complete one here like that. slide 1. Sorry, the question. The question is uh, draw or given two views, okay, with all the data there. Draw and measure the true angles between the line and the plane. Simple as that. Okay. So that's the question. Slide 2. Okay. If you draw a parallel line, okay, meaning to say you know that you are projecting it upwards where there's space there. Okay. Now, so project from point A right across and locate where is this point, which is along BC, okay, along BC on the other view, which is this view. Project it across until it cuts BC, okay, and then you join A to that point. And since this is parallel, this will be true length. Okay. Now, so you place, this is what angle? Third angle. Okay. So you place your eyes here. You place your eyes there, and then you draw your H view, which is over here. Okay. Next slide. Okay. I'm doing part of your revision actually, you know. So for ABC, all right, you make sure you draw the vertical lines. If you do not draw, I will penalize you because you are supposed to take the vertical height. All right, over here, C vertical height, B vertical height, A vertical height. All right, yeah. So you have to draw the vertical lines, all the vertical lines, point 1, point 2, A and B and C. Then you take the vertical height, okay, and then for C, transfer. Okay. Obviously, all these are parallel lines. Okay. Parallel lines parallel to your true length. All these lines, the red lines, the blue lines are all parallel to your true length. Okay. Your vertical height C, transfer. Your B from here, transfer. Your A, transfer. Okay. Your this A, the other point here, since it's parallel, it should coincide. Okay, if it doesn't coincide means your drawing is not accurate. All right, yeah. So you get ABC, one line, a single line. You please do not join AC and then separate line BC, AB. Normally, it's not straight line anymore. I mean, if you know that it is a straight line, just draw one line. Don't draw two lines for me because I can. It's so obvious, a straight line and two joint line. All right, yeah. Now, then for point 1, your height is this. Transfer. Point 2, vertical height, yeah. Point 2, transfer. Okay. Slide 3. Oh, sorry. This is the other one. Slide 4 then. Okay. once you have this intercept point between ABC and 1, 2, you trace back to this view and trace back to this view. That point, this point here. You can do both ways. Okay, you can draw the other view first. Okay, let's us draw this view first. Now, once you know that ABC, you have the true length of this line, and AB is now, you have transformed it into a single line. If you view normal to that line, you will definitely get a true shape. Okay, you will definitely get a true shape. So place your eyes here, third angle. Place your eyes here and you draw backwards. Yeah? Okay. The height, you notice I just indicate one point. Once you know where I get this line or this height, you should be able to follow point A and point C. Follow because I do not want to clutter it. Now, so for point B, this is your vertical height from your previous view. Transfer. Follow? You notice the arrow is there. So when you take this slide, when you refer it, you should be able to follow it. Okay. So likewise, for point C, this is your vertical height. Transfer. And subsequently for point A, this would be your vertical height. Transfer. Okay. And then this is your solution because it says draw and measure the true angle. Draw and sorry.
Can you
Sorry.
can you move down the question? The question is not clear, as in cannot clearly see.
The question, you should
Yeah,
have printed the question, what?
yeah, but I cannot see from your.
No, you should have your question in front of you. Your own question, not my question, not this question here. You should have printed long time ago. All right. Anyway, the question says draw and measure the true angle between the line and the plane. Full stop. So once we have done that, you should be able to uh, yeah, okay, yeah, and then if you are supposed to measure the angle between it, project backwards the point of intercept, which is slide 5. Okay, so you have to view one more time. Make sure that this is parallel to that line. Then you get two lines. So this is the angle. If you give me obtuse angle, it should be what? 180 minus 30. So it's 150. I will accept any of the angle. Okay, but you have to indicate where you are taking the angle from. And then just answer the angle in the paper, 30 or 150. This must be indicated. Okay. This is a gift, because it's in your not tutorial, in your lecture notes. This is in your lecture notes. Okay. All right. Next. Any question to this? Okay. No answer means everybody is okay. Okay. Now, that year, I I told the student that this should be given three views in first angle. Draw the ISO drawing. Okay. I told the student before they start the paper that this is an outline. This red line is an outline, complete line. Okay, complete line. Follow Okay. Now, it will be, so here, I repeat this line here is an outline. It's not a hidden line. It's an outline. Okay. Let us do this. This is your solution. Let me put it as close as possible so that you can have one slide together. Yeah. Oh yeah, I can. All right, I can. Let me remove this. Let me remove this. Okay, this is your solution. This is the three views. Okay, let me place one at a time. First, draw your overall box. Okay, you know the height, you know the width, you know the depth. So draw the overall box. All right. So now, if you do not want to draw, I mean, if you start off, you should draw it like that. I'll show you the final solution later. Okay. Now, then slide. Where's my slide? Slide one. And then I have this slide. Follow? Can you see the blue? Hang on, let me put it nicely. Okay. This trace, where is this piece? Over here. Trace where is this piece? Over there. So you should be able to draw this. 2 squares and 4 squares, 2 squares, 4 squares, and you should be able, and this is the width over here. Yeah. If you know how to draw this piece, which is this and this, you should be able to draw this and this, which is over here. Clear? It's not difficult. You just have to follow a simple step. Behave as though you are a machinist. When you are given the three views, you are asked to machine it, the first thing comes in mind is what is the overall size? So once you draw the accurate overall size, you are almost there. Everything must be in that box. Follow, huh? So you have done the blue one. Let's move on to the next one. As I say, if you can do this rectangle, you should be able to do this rectangle, which is this piece here. Okay, which is over here. Now, slide 2, which is this red piece. Okay, which is this. Okay, I don't think it's difficult. As I say, you just have to follow a simple steps. You should be able to get it. Okay, and then finally, this is one. Finally, the one below. Okay, and then you have this. Wow, hang on. Okay, okay. There's some lights there. Hang on. What I'll do is I'll slide it in, and then we'll do it this way. Yeah, much better. Okay, you can take a. I can't remove this shadow. I can't remove this shadow here. This shadow, because that is my overhead projector. All right. So that is your solution. Finally, okay. Finally, this is your solution. I place it below so that you can have all three views. I mean, all those. Okay. I don't think it's difficult. You just, as I say, you just follow. This one, point A is your highest point. Okay. Just be careful. Between lowest point and highest point. All right. Sometimes I will ask lowest point. Sometimes I will ask highest point. So my A is here. A, wait, hang on. Okay. My point A is my highest point. So my point A is here. Highest point on a piece of paper. So so it should be looking downwards like that. Okay. Any question to this before I move on to the next one? Can you explain how? Wait, let me see the question first. What did he say? Explain how you incorporate plan view into the drawing. How I incorporate? You okay. Again, let's start again. Let's start all over again. Let's start all over again. When you are given this such question, as I say, you first draw this box. Okay. You have to draw this box. The box, the overall size is obtained from here. How you incorporate? You just measure how many squares are these. So that is the number of squares. And you just measure the length, the overall length, and then the depth. The depth is obtained from here, which is this. Anyway, M4 is starting M4. This week, you'll be doing M4 this week. So your tutor would be going through your M4 tutorial with you all. Okay. Now, then after that, you can start with any of the shape. You can start with this, or this. I thought this is much easier. Either this or the red one. This. Okay. And then you would have this. The blue and then the red. Okay. Let me place it nicely. Okay, that's it. Okay, and then you place you trace where is the green piece, which is this. Finally, is this. You have to practice. There's no easy way out. You have to do past papers. So as I say, for this, the final one, which will be this. This is completely from there. How do I incorporate? You have to trace, not incorporate, because it has some hidden. You have to trace. There's no way about that. You have to practice. Okay, next question. This question. Uh, some question, you see, when we set the question, we moderate the paper. More or less, when we set the question, we are actually moderating the paper already. Okay, let's go backwards. Your this question, which is 12 marks, I don't think it's that difficult. The ISO drawing. This for that particular semester, this question is not difficult. The only tricky part is my A is now at the highest point. Once you get the A as the highest point, this is the reason. This is the reason. Let me bring out that page. This is the reason why you need to draw the overall size, the box. So you know that your point A here is your highest point. Sorry, your point A here is your highest point. Follow. Who asked me that just now? Mattel. Okay, anyway. Uh, okay. So once you have drawn, as I say, the tricky, not say tricky part, the instruction you have to follow. If I ask you for the lowest point, make sure you give me the lowest point. If you give me, and then if I ask you for the highest point, give me the highest point. If not, I can penalize you. Okay? Now, next one. let's do this question. Okay, sorry. This question is not that difficult. Average, yeah? Then your second question, 1B. This is more or less a gift, even though it's a gift, it's 13 marks. My question are 12 marks or 13 marks. All right. So this is directly from your lecture notes. The only thing I change a position. All right. And then, this one, yes, a bit challenging, but if you follow the steps, meaning to say you label your parts, 1, 2, 3, how can you go wrong? You want point 1, 2, 3, 4, 5, 6. Then you trace backwards. How can you go wrong? I've been talking about tracing of lines or tracing of points from day one. All right. So if you can trace your points, as I say, how can you go wrong? Yeah, these are simple steps. Okay. Let's go on to the last question. Second last question, actually. Okay. Okay, wait. Okay, this is the answer for it. All right, this is the answer for it. This here. Okay, let us read the question. Figure 2B, yeah, shows the plan and your front of a hollow truncated prism in first angle projection. Draw its development of the object. Begin the pattern with the seam at A1. Seam allowance is not required. All right. Now, so let me do this. So this is given in first angle. Since the pattern, the space is a bit of a constraint. There are 5 pieces. Yeah. And this is why I drew the first line. I drew the first line because I want you to start from there. If you start away from that line, too bad lah. It will not be in place. It will be some of your pieces will be out of the paper. So if I give you the first line, please make use of it, or the first point. Since I give you the first line, fine, use it. Now, since this is a truncated prism, that means hollow inside. This line, this line, this line, this line, this line are all parallel surface. This is your front because it's given in first angle. This is your plan, right? Since it's a straight line, all straight line, meaning to say it's like that. You're looking down. So these are all hollow here. So this surface is parallel to this, parallel to this, parallel to this, parallel to this. Label your parts. It's important. So bottom, you label as alphabet numbers. Hey, I'm short of one piece. Where's my slide 0? Where's my? Oh, I know why. A1 is given in your notes, in your question. All right. A1 is given in your question. So here is A, comma 1. All right. So as I say, first one, and then slide 2. Okay. What you can do is, oh, no. Wait, hang on. Let me place all of it. Don't do it that way. Do it this way. Okay. Your solution is this. Okay. Okay. You can snap the picture. Yeah, let me adjust it nicely. Okay. You can take the picture. Make sure when you take the picture, you should be able to see that green line. This green line is there. Now, your 1, 2, you are, since this is your, this is a parallel surface method. So this line here is this line. W2 is here and so forth. Where you get the vertical height from here, you just have to project it out. This is a gift, you know. It's not difficult. Okay, so refer to your notes. Your notes have this method. There are 3 methods there. Parallel surface method, parallel line method, radial method, and triangulation method. All right. Now, okay. There's some shadow there. Let me. No, you should. That's the best I can do. Okay. And then I will move this slightly down. Okay, you can snap it now. Make sure you know my green line is that green line there. That distance, transfer. This distance is this distance. And number W2 is this distance over here. Then project up. Okay. Then you trace for point 2, you trace where it cuts the vertical height, that is 2. For 3, where it cuts the vertical height with W2, that is the point. Not difficult. You just trace. That is why, in order not to confuse yourself, bottom you do it with numbers, top you do it with alphabet, or the other way around also no problem. You don't mix them. You mix them, you get confused. All right, this is a gift, honestly. Now, next one. Okay. This is the question. Draw a broken out section, which is here. Okay. Now, this is symmetrical, which if you trace, it will be this. Yeah. I've already told you all, if you are short of time, whatever is there, since this is symmetrical, this is symmetrical, this piece is symmetrical, you flip it over and all the hidden lines, 95% you're right. All the hidden lines, you darken it, and then you section if you do not have time. You're almost there. Okay, this is the question. This is the solution. That's it. And see, which is identical to the bottom since it's symmetrical. A center line. When you have a center line, symmetrical, circle, cylinder, center line. So this center line is so important. Okay. When you have a center line, as I say, is symmetrical cylinder. All right. So that is 3A. GD&T, you approach Prof. Okay, next one. Semester 1. 1819 semester 1. Okay. Wow. This question, it is so simple. I thought that semester I give a simple one. You all should be able to cope with it. All right. This question. The solution is that I just sketch it out. The solution for this is there. Or rather, ISO view, ISO drawing view. That is a solution for this tree view. That okay. Uh, okay. First and foremost, number one. Okay. Okay. Wait. Hang on. Let me get the. Okay. I can do it over here. Okay. Draw the outermost box. Okay. Draw the outermost box. You are given third angle. So this will be your plan. This is your end view. This will be your front. And this is your meter line. Okay. So draw it accurately. Then you should be able to then start drawing. Then if you draw this accurately, you will notice that this line will meet with this line when you project it up. You just need to draw this line, you are almost there already. Okay. Slide 2. Slide 2. Where's my slide 2? Or rather, this is your solution actually. Yeah. Solution for the entire question. Okay. Slide 2. Label your parts. Sorry. Okay, you can do this first actually. 5, 6, 7, 8. When when you project across, you know that point is 5, 6, and that is 8, 7. And a line here is an area here. It can be a circle, it can be a square, it can be a rectangle. Yeah. Since I promise you all I will not give you circle surface or uh, ellipse surface, whatever. So you can more or less rest assured that it is a square or it is a rectangle. So trace, where is this line? That area. In this view, where is it? Trace. So follow the blue lines. And then follow where is this green line. 1, 2, 3. 1, 2, 3, 4. Trace. Once you get there, and then finally you trace the red line. Okay, that red line there, trace it, project it up. You know that that is that piece. So it must be slanted, which is there. This is not difficult. And as I say, this is your solution. You are supposed to draw your front. Draw the front elevation of the object. That is your that is my sketch for the object. Okay. Now, uh, this I don't think is difficult. It's a gift actually. 2 lines, few lines only. Okay. Next question. Sorry. Any question to this? Any query for question 1A? Wow, this is one-way street only. Okay, never mind. Okay, next one, 1B. One B. Uh, yeah, let me turn this page so that I don't confuse you people. Okay, given this object, sorry, a solid object shown in 1B, given in third angle projection, draw the first auxiliary view in the direction of A, 45 degrees. So you can use your set square. Okay. Hidden details are required. For this case, hidden details are required. Now, in other words, at least one point is hidden. This point. This point is hidden. So you would have a line here which is hidden. At least one line. Okay. For the time being, now let's move on. By the way, this is your this is not supposed to be there. The solution is that. Yeah. And I give I drew in the ISO view. By right, you don't need the ISO view, but with the ISO view, you should be able to understand why the auxiliary view is like that. That means you are viewing from this direction like that. Okay. Okay. Now, slide 1. Okay. Note this is symmetrical. All right. This is symmetrical. So start your datum from here. Don't take your datum here. if you take your datum there, here, you have to do twice. No point, waste time. So take your datum here. Here. Okay, take your datum here. Now, when you view from here, you will see this line, this line, this line here, almost at the same time, or rather at the same time. Okay, but don't do it all together. You get yourself confused. Easier that way. You do line by line, but you take note that you are actually viewing all the three lines together. Okay, so you start off with this line. Say for instance, if you can start with this line, not an issue, or you can start with this line, no problem. As long as you label your parts, you won't go wrong. Okay, label your parts 1, 2, 3, 4. Since this is symmetrical, take your datum here. So you are only taking one distance, one measurement. Compass, measure this. Okay, this is third angle. So if you view from here, like that, this will be, you will see at this point, it will be 0.3, 2. Okay, at this point, it will be 3, 2. You see 0.3 first, then 2. And at this point, you will see 4, 1. Yeah? Now, so we start with the first point, point 1. Cutting plane, projection. Okay? So cutting, projection. So you cut point 1, passing through point 1, your projection. Your projection is based on the direction of A given. Okay? A must be given, the direction of A must be given. And I normally use 45, 45 set square or 30, 60 set square. Yeah, not random, It is, I do it on purpose because you don't need to use your protector. You just need to use your set square. Okay? So again, your compass, you take x1 distance, you swing from here, swing over. Don't you think you save 50% time? And then you do likewise for point 2 and point 3. Then you slowly form up. You slowly form the shape. Slide 2. Follow? Then slide 3. Okay? And then slide 5. Okay? How come my slide 5 is there? Oops, what is this slide? Oh, here, sorry. Okay, this is in one of the tutorial question, M3. Yeah, one of the tutorial question, there's a cut sideways like that. Okay, different shape. You can, if you have done your tutorial, you should know this piece. This piece is there. You get that. And then you have, sorry, actually I need one more slide before this. This piece here. This red piece is there. Okay, let me remove 1, 2, 3. Yeah? Let me remove all those three. Okay, yeah, this is better. Okay. Okay, got that? Label your parts, trace. Okay, point 4. AF, the bottom piece. Okay, which is that. Then finally, I told you right, you have at least 1 point hidden. 1 point which is hidden, this point here. Follow. Okay. And then let me show you the complete view. Okay, this is a complete question, a complete solution. This, not this. This is your complete solution. All right. Next one. Okay. Again, for that semester, uh, original question, original question was a line. This should be a hidden line. All right. Sorry. Let me push. This should be a hidden line. Okay. Not a outline. Because you can tell from here, if you view here whether it's first angle, third angle, this point rather, when you view from here is hidden, blocked by this line. So this must be hidden. Okay. Okay, let us do this question. Yeah, hang on. Let me push it aside. Okay, bring it up. Okay, fine. First, draw your overall size. Routine. Let me bring it down. Okay, bring it up aside. Okay, draw your overall size. And then, oh, but in actual fact, this I did not have many slides. This is your solution actually. A is your lowest point. So you are actually looking up. Okay. One thing, please take note. Normally, my thickness will be thin enough to see the slot or to see the hole. So you can see, you can see this piece here or this line. And that three lines actually carries a lot of marks. Okay, take it down, and then go in over the weekend. You can see how I do it. Okay, unless you have a question to ask for this. So this is question 2A. Next one. Oh, this one. Hang on. Wait, this one is interesting. Wait, hang on. Given a plan and a front. A plan and a front. Wait, hang on. There's a question asked. Hang on. Why question 2A, the top has a hole in that pattern? Then there's a hole. Then dotted line, right? Dotted line. Today, why? Oh, here is hollow. Uh, hello. Here is hollow. Can you see? I don't have a line here. This is hollow. If you see this is a hole, true hole. Then there's a, sorry, this direction. Then this way. Once you see the ISO, you should be able to tell. Follow. Okay, let's move on to the no reply. Okay, this question. I don't follow you, you know. Uh, I tell you what, who? Uh, Shi Hui. I will do it offline with you. I don't follow why you ask me that question. Okay, let's ask do. Okay, let us do the next one. 2B. Yeah. Why are you viewing? Why you see the object from below? Okay. Can you read for me? Point A will be the lowest point in the drawing. Okay. Since you asked me that, your homework this weekend, please draw this. From the question you asked me, I know that you have not tried. Okay. So over the weekend, draw it. Then you will know why I'm viewing from the bottom. Okay. If you think you can draw it A as the lowest point, do it, scan it, and show it to me. All right. So let's stop there. I mean, let pause there for a while. I give you some chance. Weekend, do it, and then prove to me that I'm wrong. And what is 2A star? Okay, anyway, I don't follow you. Okay, I'm okay with it. Uh, let me proceed on because the thing is that you have not tried. Then you are also holding the whole class back. If it's a fast question, no problem. This is because you have not tried. You are not aware why we are doing it that manner. Okay, let's move on. Okay, this question. So what do you have to do? Very simple. That this is a solution. The solution is not that important. How you get the solution is more important because this shape will not be the same. In the exam, it will be another object, but the statement will be the same. Draw given the plan and the front. Now it is I've said that it's a hollow truncated pyramid. Okay, in first angle. So this is your front. Sorry, this is your front. This is your plan. Follow, Now, draw is development of the object. Begin the pattern with seam A1. A1. Okay, 1 is somewhere here. Seam allowance is not required. Now, first, first and foremost, I don't need even to define that is hollow truncated. I don't need even to define its first angle projection because of this line here. This line. You see, if I view from here, I know it is a first angle because I view here, I throw my view on the opposite side and I can see this line. Yes, since I can see this line, meaning to say this number one is truncated and is hollow. All right. Number two, it is first angle. Okay. Then, as I say, normally I have two numbering system. Whether alphabet bottom or alphabet on top doesn't matter. Alphabet bottom, numbering on top, okay with me. Okay. Since I've labeled A, so just continue A, B, C, D, and so forth. So somewhere here you use numbers. Okay. Now, once you have labeled the parts, and I've also given you the first line because the space is a constraint. Once the space is a constraint, I will definitely give you first line. If the space is obvious, you have enough space, I won't give you even the starting point. Okay, so label your parts. This is your solution. Let's us do the solution. Okay. Now, your A1, since A1 is given to you, the label is there. Since A1 is parallel to your datum here, this A1 is true length. So straight away, you have this true length here. And point 2 is on the A1, so point 2 is also true. like that. So you have A1, point 2 is true, so you just have to take the, where's my compass? You just have to take, either you can take from here or you can take from here, no problem. So if you take from here, transfer, okay? Or you take from here, then from the bottom, follow, okay. Now, where are we now? Let us open uh, AB, AB, oh, this surface, okay. That means, let me open this surface here, okay, this surface here, okay. Now, so you have, wait, hang on. See, like this. Now, let me ask you a simple question first. Do we know the distance of AB? Do we know the distance of AB, which is here, AB? Now, why I ask you to label your parts is simple, very simple. AB is parallel to your datum. Yeah, meaning to say this AB is true. So, with your compass, measure this, cut one arc. One arc. A point you need two arcs. Okay. Now, next question. I've already said a point you need two arcs. So you have only done one arc from A. Next question. 1B is, where do we get the true length of 1B? Since 1B is not parallel, so meaning to say you can't get it from here. Yeah. And 1B here is also not parallel to the datum. So this 1B here is not true. Meaning to say, i.e., you have to draw a true length diagram. This blue one, because I ran out of space, so I drew a construction line. As long as I can see it, fine. If there's no construction line for this true length diagram, you are wrong. I assume that you guess, or you turn your head to the left or to the right of your neighbor. So if I don't see the true line diagram, construction to true line diagram means you have done it by guessing. Turn upwards to God. What do you mean by that? Oh my God. Fine. Now, once you okay, with respect to B1, the vertical height is this much. Yeah, B is here. B is here. 1 is there. So this is your vertical height. Yeah. Okay. With respect to B1, where do we get the base? We obtain it from your plan. B1 is here. Okay. B1 is here. Transfer. From here, transfer. Follow, okay. So you have your vertical height, your base. So this is your true length of B1. Okay, take this true length of B1, cut. Cut. So you have point B. Now, since point 3, where's point 3? Since point 3 is along B1, you just have to project horizontal line. Be careful. Can you see a horizontal line here? From point 3, a horizontal line. So I need to see that horizontal line. Okay. I need to see this horizontal line. Yeah, it is a small distance, but I do need to see you draw that line, construction line. Okay, so once you have drawn that line, you should be able to get 1 3. Okay, 1 3. So what you have already obtained B, you just have to need the true length of 1B, 1 3, and then cut along the line. So you should be able, once you have drawn that surface, then you proceed on. This is the first surface, which is this surface. Once you know how to do this, you should be able to do this, and then back to it. So let me include all this, then you can snap. Okay, first, just snap like that. Got it? Okay, let me put over. Let me place it nicely, so that you all can take it. Okay, hang on, hang on, hang on. Okay, take something like that. Okay, and then over the weekend, put in some effort. All right, yeah. Any question for this? Hello, any question for this? Not at the moment. I asked you to draw. Can I go through the construct? Oh, you want to? Okay, fine. That is also construction line. Okay, fine. Only a few construction line. Label your parts, and then you need to ask a few questions. Where is the seam? So the question asks you to start with A1 as your seam. So that is your opening. Now, then the next question you should ask is A1. Is A1, where do we obtain the true length of A1? A1 here is not parallel, so this is not true length. So, however, A1 here is true. A1 here in the plan is parallel. So therefore, this line is true. A1 is true. So since point 2 is along A1, point 2 is also true. That means either 1, 2 or A2 is true. Okay. Then that's how you have the first line. That's how you the the blue line, correct. This line from here to here, A2 is this line. That is true, which is sorry, there's two. I try to avoid using the same color. The blue line of A2 is this. Okay. Now, why I use the same color is because I developed AB32. Now, B1, B1, you notice that B1 is not parallel, so you can't get the true length from here. B1 is not parallel, so the B1 here is not true. So you have to find the true length diagram. That is why I drew this line, okay, which is there. Now, with respect to B1, all right, wow, this is your vertical height, true height for B1. Where do you get the base? The height is always obtained from your front, please. Your base, I'm doing your revision actually, I know that you have not you did not do your revision actually. So your base is always obtained from your plan, which is this. Take this distance, cut or transfer. So this is your base. This base here is from here. Okay, yeah. Oh, sorry, can't see it. Hang on, let me push it up. Okay. This base here is from here. Okay, this base here is from here. Once you have obtained this true length diagram, which I need to see, if I don't see your true length diagram, you won't get a lot of marks. Okay, so once you have obtained the true length diagram, true base, true height, so this is a true length diagram. This is our true length for B1. Cut. So since point 3 is on the B1, project, I need to see the horizontal distance. From point 3, draw a horizontal line. If you notice, there is a horizontal line here. I show you. There. Okay, that horizontal line I need to see. All right. So once that horizontal line can be seen by me, I will give you that marks. Okay, so you have point 3. And then you proceed on. Do some revision, Nicholas. Okay, next one. Okay, next one. Okay, you are supposed to do, wait. You are given an object in third angle. So if this is given in third angle, so this is your front. This is your plan. Draw a sectional view of BB. So cut here, BB arrow pointing here means third angle, you throw your view backwards. So here. How can it be on top or at the bottom? Definitely is at the bottom. All right, cannot be on top. Some of you draw at the top. For what? What's the point? Your cutting plane is here. So draw it, and there's no space to draw it here. So it's obvious I want you to draw here. Even though you, okay, I don't want to proceed further in that direction. Since you are given a space, Meaning to say, I'm telling you, hey, hello, the answer is there. Place it there. All right, not on top, not it must be here because the arrow with the cutting plane is here. Okay. Outermost dimension, horizontal line. Outermost dimension, horizontal line. Sorry. Outermost, draw one vertical line. Okay, and then from here, draw it down, and then you get a meter line. Join all the 3 points, you should be able to get that meter line. Okay, yeah. Okay. So once you draw the meter line accurately, please, you should be able to do your solution. Wait, first one. First one. Now, let me adjust it slightly. Now, I have to go. I think I have to stop after this. Now, when you are cutting here, you trace where is this circle. This circle, can you see a dotted line here, dotted line here, dotted line here, dotted line here, and center line, meaning to say this is a circle, this is a circle, this is a circle, through, right through. Yeah. Now, when you cut this is a cylinder or a hole rather, circular hole. Yeah. You, this is a circle, you know, definitely you cannot section this part or so this center line will indicate it. So you have this hole, circular hole right through. This hole will be here. This hole you project across is here. So I need to you need to draw a few construction line to bring it down. I omitted that. Okay. So you have this. When you cut here, you should be able to get this. Okay. Slide 2. You have this piece. Trace. Trace that line. Trace that line. Then you can bring it down. So you know it's there. Okay. And then slide 3. That green line there. And to have the complete view, you would then have this. Sorry. Wait, let me do it properly for you. Okay, hang on. How do I put this? Yeah. Let me remove all of this. The solution is that. Sorry, I need to. You need to include the center line. Center line for the circle. For the hole. All right. All right. I need any question to this. Hello. No question. I have a question regarding Justin, you send by email, some use this chat, some use email. My God. Okay, so there's as I say, GD&T, please approach Proctor. He'll be back next week. All right. I have to end here. Some of you have to be in the next class. So let me stop here. And then I have anyway I have a tutorial question some class later on.